So our multi-purpose building was experiencing extreme heat during summer, and it basically became unusable for a few days in term 1 and in term 4. And so not only was it a problem for the school, but it was also a problem for the community groups who use the school building on Saturdays. And it's a lovely shell of a building, but there was very little insulation put into it, very little thought seemingly into how we'd manage the thermal capacity of the building.
When we actually got into the building, we found that it was very lightweight and its construction was not that good from an insulation perspective. And the problems were quite systemic in that it was radiant heat. Yeah, that radiant heat load is quite evident when you're inside the building, and rather than trying to pull heat out, it became apparent that more of a passive solution was required. And Cool Roof is one of those. That's great. We've done it before and it's worked. Yeah, if we can stop the heat getting in, then we won't have a requirement to take the heat out. And it's all very low energy, and that's what regenerate engineering likes to implement, is solutions which give the comfort, give the outcome, and don't cost the energy.
We were invited to Fairfield Primary School through a consulting engineer, John Fettes. We'd done a number of projects with John in the past. He invited us out here to have a look at an issue that he had, and it was quite a unique issue. The building's predominantly a box, so on high ambient days, that heat is actually collected onto the surface area. And it was difficult because it couldn't use refrigerated air, such as air conditioning. Because it's a gymnasium, we couldn't look at doing ventilation via axial fans. The reason we were asked to attend the site and review the problem that they had with internal heat load was to see if we could affect the internal load and remove some of those heat issues internally.
Ever since the building was built, it's been an issue during summertime. So our school council has been looking at it for a while. The community expectations around it has been that this building needs to be fixed.
One group that did express concerns were our after-school care group. So they would use it from 3:30 onwards, and often you would find that was when the heat was most excessive, and there were days when they would have, significant numbers of students, which that space couldn't cater for. Also, we would hire it out to a basketball club, and as you can imagine, playing basketball in 40-degree heat where there's no cooling, they ended up having to cancel a lot of their sessions. And keeping in mind they're one of our main hirers, it wasn't good for maintaining a positive relationship.
The main thing that differentiated Cocoon from other options that we looked at was that it was a passive solution, so it didn't require any ongoing investment in terms of energy, and that was good for the environment. Another thing that was really important for the Buildings and Ground Committee is the improvement in the longevity of the roof. So when we're thinking about the life cycle of all the materials that have gone into the building, if we could increase the lifespan of that building material, that's another win for the environment.
It's actually surprising how many buildings have a need for a radiant cool roof coating, and how much difference it will make to those buildings.
Environmentally it's sustainable. It's projecting that positive image of sustainability, which the school wants to promote. It's also cost effective as well as energy efficient. And also it was quite low maintenance in terms of the installation and the operation.
The product does conform with building codes of Australia, so it makes it quite an easy transition between our engineering and then approval for application. The market is moving for passive cooling. It's been well and truly accepted in the United States and throughout Europe that this is an efficient method and a good application to keep power costs away.